All right. So far we have answered our 6 key questions, and we've also discussed the biomechanical principles, the philosophies of design, the importance of selecting the right primary abutments, then the need for an optimal path of insertion, then the need for an appropriate guide plane in order to limit the denture movement, both in function as well as in insertion and removal. Now let's go ahead, consider the design sequence and design elements. In general, after we delineate the path of insertion and we select our abutment teeth, we just go ahead for trying to choose the position of the rest. So the sequence of design elements that is followed likely is the rest, further the major connector, minor connector, followed by direct retainers and indirect retainers. Answering our next question, rest seats and their location. It is well understood that the rest controls stress by directing them along the log axis of the abutment teeth. And a correctly positioned rest is required to ensure efficient function of the clasp. The floor must be always less than 90 degrees, otherwise, as you see here, the tooth as well as the partial denture move away from each other because of the inclined plane effect. An important consideration is in the distal extension, where the rest seat should be saucer shaped to allow some movement of the rest so that the forces are not transmitted to the abutment. Next, in case of tooth bone condition, where is the rest seat location? It should be placed adjacent to the edentular space on both the ends. Then in cases of Kennedy's class 1 and class 2, this is a crucial judgment. In case you consider a conventional simple circular clasp, then what happens on occlusal load? The denture base tends to move tissuewards. What happens to the clasp? The clasp tip tends to lift out, and also simultaneously it tries to transmit a force onto the abutment tooth, which then most likely leads to a torquing of the abutment distally. So remember, underline it, that we are not supposed to indicate a circumferential clasp, that is a simple circlet clasp, in case of a distal extension case. Then what is the alternative? The alternative is to have a mesial rest preferred on the edentular side. Then this results in a reverse circlet clasp, which is engaging the distobuccal undercut. Then on occlusal load, when the denture base moves towards the tissue side, what happens to this clasp? The clasp tip tends to go ahead, sink gingivally, and it also tries to come out of the contact of the tooth, and so there is no force that is transmitted to the abutment tooth. So this is the alternative that is considered in distal extension cases. Then another school of thought says that since we have considered a reverse circular clasp, it can definitely have a wedging force when placed between the adjacent teeth. So to counteract this, it is advocated that go ahead, place a distal rest so that this forces can be counteracted. That is the distal rest never preferred? Only in very special conditions do we have the distal rest preferred. That is when the abutment is rotated or in case of a large restoration on mesial side. What do we do when it is severely weakened periodontally? Then we may have to move the rest more anteriorly. Next, coming to rest seat and clasp position. Do you think they are related? Yes. Rest seat position influences the clasp position because it tries to go ahead define our fulcral line, and it also influences the undercut. One thing to be noted is position of the retentive clasp is more important than the number of clasps that is used in the design. Then the number of clasps is used, the number of clasps that is used is determined by the Kennedy's classification. So we basically have 3 configurations, the quadrilateral, the tripod, and the bilateral. The quadrilateral configuration is considered in cases of Kennedy's class 3 with a modification space. As seen here, we would go ahead, clasp the tooth that is adjacent to the edentular space. So we get a quadrilateral configuration. And this is said that it is one of the best in order to go ahead distribute stress. So in case of a situation where we do not have a modification space and teeth are present here, still we go ahead, aim for this quadrilateral configuration. Then coming to the tripod configuration. This is seen in cases of Kennedy's class 2. So we would be connecting these occlusal rests which are placed across the edentulous span, and the tooth-bound side. Then we get a triangular configuration. So again here, if there is no modification and there are teeth present, then we have no choice. We still go ahead with the tripod configuration itself, though it is not as effective as the quadrilateral. And what happens in case of a class 1 situation? We have the bilateral configuration where we go ahead, place our rest and the clasp adjacent on the tooth that adjacent to the edentulous span. So now coming back to our ideal situation. Here we follow the bilateral configuration as this is Kennedy's class 1, and we have the mesial rest placed on the 3-5 and 4-5. Moving ahead, which is the major connector that best connects the RPD components? Amongst the different type of major connectors that are there, only a few are said to be more effective in cases of distal extension. Why? Because distal extension cases are very challenging because of the rotational forces. So here in the maxillary major connectors, the broad palatal major connector or the complete palatal major connector is the one which is more effective. And it definitely provides good support, retention, as well as stability with a broad stress distribution. Then in mandibular major connectors, the lingual plate major connector, which is properly supported by rest, is the one which is considered to have broad stress distribution and also support periodontally weakly and also provide cross-arch stabilization. So coming to our ideal situation here we would be going ahead considering a lingual bar in case we have periodontally sound anterior teeth and an 8 mm of vertical space is allowed between the gingiva and the floor of the mouth. Otherwise, we still have another consideration of lingual plate with cingulum rest that would be present. Now let's break in for another question for you. So, which of the following major connectors provide the greatest rigidity with minimal palatal coverage? The options you have: single palatal strap, B, U-shaped connector, C, anterior-posterior palatal bar, and D, the complete palatal plate. Place your answers. Let's check. The answer is C, that is the anterior-posterior palatal bar. Because of its closed design, it tries to resist bending and provides rigidity. Let's move ahead. We now come to the minor connector. So what type of minor connector is to be considered? As we all know, minor connector connects all the different components to the major connector. But some key points to be noted is that the minor connector also maintains a path of insertion via contact with the guiding planes and offers horizontal stability. There are basically two basic types of minor connector. The minor connectors that are placed into embrasures between two adjacent teeth and the gridwork minor connectors that connect the denture base and teeth to the major connector in cases of distal extension. Now, what is the thumb rule for the extension of this gridwork minor connector? In case of maxillary, we have the entire length of the ridge to be covered up to the tuberosity. And in case of mandibular, only 2/3 the length of the edentulous ridge is covered, along with having a tissue stop. So as you see over here, we have the lattice type, we have the grid type, we have the beads. So any one of these can be considered. Another important feature is the acrylic resin finish lines, which is usually missed out. So in case of our fabrication, we always have to incorporate both the internal as well as external finish lines. And it's also recommended to have an offsetting so that we have maximum bulk of resin for the strength and retention. So the internal finish line is located on the tissue surface of the RPD as seen over here. And the external finish line is located on the polished surface of the RPD. It is formed, both actually are formed during the wax pattern fabrications on the refractory cast as we are constructing the framework. So considering our situation here, as per the principles of the grid work minor connector, we are supposed to have this edentulous span divided into 3, and then we go ahead, have our 2/3 of the edentulous span covered with the grid work, and further we go ahead, place our tissue strap. So this tissue strap helps us to have a control space for the resin to flow, and then further we have the internal finish lines and the external finish lines. Now coming to clasp position versus number of clasps, we've already discussed this, and we have to underline that the more than the number of clasps, the position of the clasp is more important. Another key factor is that a clasp should always be passive on complete seating. Whenever the denture is inserted, then the reciprocal arm should first contact the tooth before the retentive arm. Remember this. Why? Because as the retentive arm passes across the height of contour, what happens? It tries to have forces exerted. And to counteract this, we want bracing and stabilization from the retentive arm. Therefore, the name is, bracing and stabilization from the reciprocal arm. And therefore, the name is reciprocal arm. Another point is the ideal position for the retentive clasp is the gingival third of the clinical crown. Next, moving on to clasp length and material. So more flexibility is obtained when the length of the clasp increases. So instead of trying to go ahead have a straight contour of the clasp, we can always have it curved to increase the flexibility, reduces the stress on the abutment. Next, coming to the clasp material. So chrome alloy is more rigid and will exert greater stress. As we have no noble alloys that is practiced in our country, we have most of it always being fabricated with the casted chrome alloy. So what we can do to counteract this, we can try to have the diameter lessened, okay? That is, a smaller diameter can be used and lesser amount of undercut can be engaged, okay? So the chrome alloys or the casted chrome alloys are always for the 0.01 inch undercut. But for the wrought wire clasp, we can always engage more undercut as seen over here. It can go up to 0.02 to 0.03 as well. So now, another question for you. The usual number of direct retainers used in a Kennedy's Class 1 RPD. The answer, I suppose you already know, that is 2. Next, moving on to the clasp design. Which one do we choose? Infrabulge, suprabulge? We've already discussed about the indications, contraindications of the circumferential clasp and the reverse circular clasp. So moving on to the vertical projection or bar clasp. This is similar to the reverse circular clasp, and this is also used in distal extension cases when the distobuccal undercut is present. All right. There is another school of thought here. As seen over here, we have the distal rest in this vertical projection clasp. Here, it is said that by having a mesial rest instead of the distal rest, we would shift the force anteriorly, and so this concept advocates using a mesial rest. All this while, we were discussing about the undercut present distobuccally. But what if the undercut is present mesiobuccally? Then we use a combination or a wrought wire clasp. So the combination clasp is similar to the cast circumferential clasp, only with the exception that the retentive arm is fabricated with a wrought wire. And the wrought wire retentive arm here gives us more flexibility, and therefore there is less stress distributed onto the abutment. Some more key points that you are supposed to consider during clasp designing. Always keep the clasp retention minimal, although you have to consider adequate retention. Then in cases of distal extension, you can always consider other factors for the amount of retention. They are those physical factors of adhesion and cohesion, and the atmospheric pressure, and the frictional control by guide planes. Then the neuromuscular control that is achieved by properly contouring the polished surfaces of the denture base, that is having the appropriate concavity and convexity as per the muscle attachments and the tongue. Now coming to our situation here, we have two choices again. As we have already mentioned, we can go for the reverse circlet clasp engaging the distobuccal undercut, or else we can go ahead for the bar clasp engaging the distobuccal undercut. Now, this is a short question for you. What are the 6 factors required for clasp assembly? Let's quickly have a look. Keep this in mind, it's very important. So we have the support, stabilization, and retention that is provided by the clasp assembly, along with the considerations of encirclement and passivity. Now we move on to the 12th question. Whether an indirect retainer additionally is required beyond the direct retainer. Of course, the answer is yes. Why? Because we would be shifting the fulcrum, which is placed at the rest seat, more anteriorly when we go ahead, place an indirect retainer perpendicular to the fulcrum line. So the definition says it all. The component of removable partial denture that assists the direct retainer in preventing displacement of the distal extension denture base by functioning through a lever action on the opposite side of the fulcrum line when the denture base moves away from the tissues in pure rotation around the fulcrum line. So what would be the number of indirect retainers? In Kennedy's class 1, it is necessary that we place it far away from the fulcrum line as possible. And in Kennedy's class 2, we have it present on both the sides of the arch, whereas in Kennedy's class 3, we do not have an indirect retainer. What would be the design of the indirect retainer? It can be an auxiliary occlusal rest, a canine extension, or it can be a canine rest, a continuous lingual bar or a plate. In maxillary dentures, we can have the Ruge support and also the direct-indirect retention from the reciprocating arm anterior to the fulcrum line. So in coming to our ideal situation again, here we would have our rest seats placed on the canines so that we have a major connector of a lingual plate with cingulum rest, which would provide us with frictional resistance as well as indirect retention. Moving on to our next question, do abutment teeth or the residual ridge require protection from external forces acting on the RPD? So here we have to check two things, the periodontal status and also whether the abutment needs protection or the ridge needs protection. Suppose the abutment is weak, then we go for a combination clasp as it has more flexibility. And in case of a periodontally sound abutment teeth, we go for a less flexible clasp, that is the bar clasp. The displaceability of the residual ridge should be considered whenever there is decreased vertical support because there is less lateral stability of the denture base. Such in case, we would definitely ensure for a broad stress distribution, and we would also consider a functional impression. Then what are the tooth modifications that are required for a design? So enameloplasty and dimpling would be undertaken in case we do not have the desirable undercuts that is present. Basically, these are the intentional reshaping of the enamel, not always followed except for when we do not find a desirable undercut. Remember, it is not effective if both the opposing surfaces of the tooth are sloped. The next modification that can be considered is the fixed splinting, as seen over here in case of a lone standing tooth that is present, and also in case the abutment teeth are of shorter roots and it is tapered, then we can have a combination of a fixed processes with a bridge over here as well as the removable RPD. But one important point to note is extremely weak teeth should never be splinted with strong teeth. Removable splinting, should it be considered? When a fixed is possible, removal is never considered. In such a case, when removable splinting is considered, we need to have more than one tooth clasped for cross-arch stabilization. Another consideration is the attachments. Such mechanical connections can be considered in case where we require stress breaking, and also when we are designing a combination processes with a fixed and the removal. Popularly, we have the Sika attachments. We also have the O-ring attachments, which can be looked into. Denture bases, metal acrylic resin. Yes, of course, acrylic resin is most commonly used. Metal denture bases only when in cases of tooth supported conditions as in class 3. Impressions of selective pressure has to be considered with the stress bearing areas in mind whenever we have a long span edentulous condition. This is something very important. Occlusion and artificial teeth arrangements in RPD. Occlusion should be in harmony with TMJ and neuromusculature. Always deflective contacts to be avoided. Initial occlusal contact should be always in the remaining natural teeth, and never should our metal or artificial teeth guide the mandible into protrusive or lateral movements. Always consider the opposing dentition, because if the opposing arch is with natural teeth, definitely the forces that will be acting is different and the contacts will be differing. Reducing the buccolingual width and the number of replaced teeth will definitely reduce the stress. Contact of natural teeth should be same whether the denture is in the mouth or not. Steep cuspal inclines on the artificial teeth should be avoided because they tend to introduce horizontal forces. Another very important thing is the area of the applied load. Where should the load be applied? It should always be centered amongst the span of the teeth at the center, both anteroposteriorly and buccolingually. So that that means you should be placing more number of contacts here and not on the distal side. If there are sufficient centric stops, then maximum intercuspation is utilized. And in certain cases of class 3, many times you can start hand articulating it. You don't even require to go ahead, mount it. But in case there is insufficient centering contacts, suppose you have all the teeth posterior to the canine missing, and in such a cases, we'll have to go ahead, record the centric relation, and then give the centric occlusion according to the centric, consider the centric occlusion later on. So we will be having the MIP at centric relation. This is the summary. The key considerations and the points to be remembered in class 1 and 2. So far, we have discussed all. I have listed it here. You can go through. And for the class 3, this is for the class 4. This is another important point which I had to bring it to you. That is the digital workflow in planning CPD. Now, since we are digitalizing our workflow, kindly keep a note of this. So this is from the Dentcare lab that I have to place here. Here the Dentcare lab uses the ExoCAD with the 3Shape software, and they provide us with the Define Pro or either the Define Plus scanner. So these are certain images of the workflow, as you see here, how the undercuts are blocked, and then we have the design fabricated, we have the trial done, and finally we have the denture. So finally, we have come to the end of the session. So let's summarize our design principles. Always minimize the framework elements that you're considering and make it more hygienic and self-cleansable. Obtain good base adaptation. Use what is already present. Plan for the future. And never plan an RPD using a single cast. Avoid occlusion with centric contacts on the rest and heavy buccal contacts on the denture teeth. Last but not the least, when other dental treatment is planned and an RPD will be made at the end of the treatment, always plan the RPD first. I conclude by having my sincere thanks to both my university, JC's Academy of Higher Education Review, Education and Research, and the Cayley Institute of Dental Sciences, Belgaum, where I graduated from. My sincere thanks also to Dr. Rangarajan sir for his vast information that we have had in his textbook of prosthodontics, and always our loved Stewart Clinical Removal Partial Prosthodontics textbook. Let's have the questions.